In May of 2023, a verified news account posted a breaking photograph of an explosion at the Pentagon. Within seconds, the image went viral across social media, triggering an immediate panic on Wall Street. This line graph shows the sudden plunge of the Dow Jones Industrial Average on that morning. In exactly 2 minutes, $500 billion was wiped from the stock market. But the explosion never happened. The image was entirely fabricated by an artificial intelligence. Science fiction spent decades teaching us to fear glowing red eyes, killer cyborgs, and violent robot uprisings. The reality of artificial intelligence is much quieter and much messier. The AI revolution poses a challenge more subtle than physical destruction. It systematically dissolves the boundary between reliable reality and synthetic noise. For most of computing history, machines were entirely dependent on rigid, human-programmed instructions. They were essentially high-speed morons doing exactly what they were told. Even when IBM's supercomputer Deep Blue defeated world chess champion Garry Kasparov in 1997, the machine wasn't strategizing. It was searching through 200 million possible moves a second, winning through sheer brute force mathematics. Computer scientists realized that if they wanted machines to actually learn, they needed to look at us. Humans do not navigate the world by memorizing massive lists of rules. We take in a constant, chaotic stream of visual and audio data, and our brains learn to spot the patterns. To replicate that ability, engineers discarded the pre-programmed rulebooks. They built an entirely new architecture, modeled directly on the trillions of synaptic connections in the human brain, the artificial neural network. In modern medical diagnostics, the weak link is often the human eye. When a doctor looks at a patient's scan, the physical patterns of early-stage lung or breast cancer are sometimes too microscopic and subtle for human vision to detect. This is where a specific type of artificial intelligence called a convolutional neural network steps in. It combs through a medical image using hundreds of virtual magnifying glasses, scanning exclusively for highly specific edges, shapes, and textures. When the software guesses what those shapes represent, it checks its answer against thousands of historical medical cases. If the guess is right, the mathematical connections that led to that answer are strengthened. This feedback loop, called backpropagation, forces the system to get smarter with every scan. The results are highly precise diagnostic tools. AI models like Mirai and Sybil can now review a patient's scan and predict the development of breast or lung cancer up to 5 years before a visible lesion ever forms. By cutting through the chaotic visual noise of human biology, these networks are turning medicine from a practice of treating advanced disease into a system of proactive prediction. That exact same architecture of finding patterns in data scales to decode almost any complex system. Researchers trained a neural network called AlphaFold on thousands of known protein structures. It leveraged that data to successfully predict the three-dimensional folding shapes of 200 million proteins, nearly every protein known to science. Knowing exactly how those proteins lock together allows scientists to skip years of trial and error, quickly inventing cheaper drugs that fit perfectly into disease-causing molecules. On a completely different scale, emergency dispatchers in California are using neural networks to monitor petabytes of mountaintop camera video. The algorithm scans massive, overwhelming landscapes to instantly spot the microscopic visual anomalies of nascent megafires. Whenever humanity faces an impossible ocean of data, neural networks serve as a hyper-efficient tool for isolating the life-saving signal hidden inside. But there is a catch. The exact same mathematical structures that predict the shape of a protein, or the next word in a sentence, can easily be inverted to generate complete fabrications. Look at diffusion. Algorithms are trained to systematically corrupt billions of clear images, destroying pixels step by step into pure static noise. Then, running in reverse and conditioned by a text prompt, the software reverse engineers that static into an entirely new, hyper-realistic image. That diffusion process is exactly how someone typed a prompt into a computer and generated the fake photograph of the Pentagon explosion. The barrier to entry for mass manipulation has cratered. A comedian like Jordan Peele can seamlessly graft his voice and mannerisms onto the face of Barack Obama, creating a perfectly convincing illusion from a standard desktop computer. The same technological engine designed to help us decipher the world has democratized the ability to completely distort it. We are injecting this synthetic noise into a global ecosystem already suffering from a deep distrust of media and academic institutions. The existential threat lies in a society where photographic and video evidence can no longer be trusted, a more immediate crisis than any science fiction supercomputer. Artificial intelligence functions as a mirror, acting as the ultimate amplifier for whatever human intent we feed into it. We have built a visionary partner capable of spotting cancer and stopping fires before they spread. Reaping those benefits requires actively building the guardrails to ensure it doesn't drown our shared reality in noise.